This is the fifth video of the particular water quality prediction. So in this particular video we are going to see about the preparing the data for the training of the model. Okay, the training of machine learning model. So we already know that df.head whenever we are going to do, so we will have some features and targets. So we till now we have not split it into features and the target, which is going to be your features, which is going to be your target. And the second one is that you have to do the pre-processing. That is basically we want to do the standard scaling of this data, because now data for particular pH we are getting, you have the range from 0 to 14 maximum, but for the hardness you might have the range, or the sulfate you might have range from 0 to 100, 300, 400. Okay, so that, or even for the solid we are getting 2000, 20,000, 30,000. So this, whenever we are going to plot this thing in the same, we can just say that because the pH you will get, if that is maximum you will get the 14, and now that 14 value you are going to compare with the solid maximum value you are getting as 40,000 or 50,000. So what your main aim is that you want to keep everything at the same scale. So everything is the same scale. Basically you want to keep with the help of same scale. It means like between 0 to 1 or the -1 to 1 means every column will be have in the same scale. And we want to do scaling of only the numerical column, except the we don't want to do the that is for portability. We don't need any scaling. We only need scaling for our features, that all I think all contains the numerical data, and that is basically a float data type. So we have to do the only the pre-processing for the that is all the features. And for that pre-processing, why we are, it is really important, because every features you want, every features or every column you want to scale in the same. You want to scale between 0 to 1 or -1 to 1. So that is really easy for the machine learning model to understand, because one column you are getting something value 0 to 14, something 3, 4, 5, and the second column you are getting as 50,000. So that's fluctuation from 14 to 50,000. That is really hard for the machine learning model, and that machine learning model will not able to learn properly, we can just say. Then with the help of this particular, we can able to say that, like with the help of scaling, we can just scale all the particular features in the same dimension. Okay, so now first before scaling we have to just split the data into features and the target. So in the x we contain the features. So x is basically your the features. So we can just write here df.drop, that is basically the last column you don't need for the features, that is a portability. I can just copy and paste. Okay, and we can just mention that x is equal to 1, means we are going to drop across the column, and the y is basically your df, and I'm just going to take only the portability. This one I have just done now. Okay, so this basically you have the x and the y is basically the target, and x is basically the features. Now you can just check the shape of that, x dot shape comma y dot shape. So once we have just done with the shaping part, we are able to see that 3276, that is total number of rows we have. But for the total number of features, that you have 9, and for the target we already have only one column. Okay, so now the second thing is that we want to do the pre-processing step. For that we have to import the library, that is a standard scaler. We are going to import every library here only. Okay, that looks really good from that is from sklearn. Now I will say about the sklearn. sklearn is basically a scikit-learn library. That is a library we call as a scikit-learn, and whenever we are importing we call as a sklearn. So sklearn is basically all the machine learning model. Whenever all the machine learning algorithm, all the machine learning pre-processing step, all the machine learning matrices you are going to find inside the sklearn library. So sklearn library is basically dealing with all the machine learning library. Even all the, if you have, you're going to do anything, if you are going to work with the machine learning terms, so we have to just go with the sklearn, because sklearn that contains all the library, whether linear, logistic regression, random forest, decision tree, this different type of library, you can just go with the sklearn. Okay, this is what we are just writing here. So what we can just write here, so basically I'm just writing importing this one. So the how I can import from sklearn dot pre-processing. Okay, so I'm going to import standard standard scalar. Okay, this is what we are going to do. So now whenever we already have imported, we will make the object of the standard scalar. Okay, so scalar equal to standard scalar. Standard scalar basically x minus mean by standard deviation. This is the what formula it is. It is going to scale everything with the mean and the standard deviation. Approx it is going to be between -1 to 1. Okay, and now for the x, what we want to do is scalar dot fit underscore transform. So what do you mean by fish underscore transform? Basically what we are doing here, we are just scalar, we are just taking the standard scalar, that is the exact the library, and then from that we are just calling one method, that is a fit underscore transfer. Fit is basically it is going to calculate you the mean and the standard deviation of your data, and transform means it is going to apply for the all the columns in the particular x variable. Okay, total number of features we have the 9, that is a 9 columns, then we can just apply for the every columns. Okay, this is what we are going to get. Okay, even if you want to print this thing, even you can just write here x and you will get something like value minus 0.6 something. Okay, so you will get in the range, if you will get everything in the range, you are not going to get range between minus something like one value you have 2 and for the second column you have 50,000, that you are not going to get with the standard scalar. Means you have just keep every data into a one scale, and that is really a good for the machine learning algorithm. They don't have to bounce back from 50,000 to 3 back. Okay, this is what we can just do with the standard scalar. The next part is basically splitting your data. Now you already have data set, but you need 80% of data set for the training, and the rest 20% data you need for the testing. So for the splitting data, which library we are going to take, we are going to use the basically from that is everything. Whenever you are dealing with the machine learning, you will use the sklearn library from, that is sklearn dot model selection import train test split. Okay, this is what we are going to do. So this is train test split. Basically it is going to split your data into training and the testing. So what we need, train test split, and you have to pass two things, that is the features, that is x comma y, and the one more parameter, that is a test size. Basically how much test percentage you are going to take. If you am just taking 0.2 automatic for the training side, it is going to take as 80%. Okay, this is what we have to pass, and it returns four particular variable, that is x underscore train comma x underscore test comma y underscore train comma y underscore test. Okay, this is what we are going to do. Once we are just running, you can just check the size of this particular, say for size, whenever we are just going to be x dot train dot save, or even x dot test dot save. Okay, means total now the training data is total 2620. You have the training data, and for the 656 is basically we will use for the testing data. Training data basically means during the training of your model you need that training data, and for the testing we need total 656, means that data does not seen by the model during the training time. Okay, so this all the data you have prepared. In the next video we are going to start with the first algorithm, that is a logistic regression. Thank you.